Hey there, everybody. This time let's talk about adding vectors with components in unit vectors. And because what we did before, and we'll review that, is we added vectors graphically, hooking them up head to tail. But that's a great way to get an estimate of what your answer should be. But if you want a really mathematically rigorous answer, you need to be able to add them together mathematically. And to do that, we need to understand what vector components are. So we're going to be dealing with vector components. And then we're going to be expressing those vectors in components using what are called unit vectors, I hat, j hat, and k hat. So I'll be explaining what a unit vector is and how to use them. And then we're going to actually do all of this by adding two vectors together using this technique, this procedure. So let's get started. Okay, so let's suppose I'm going to add two vectors together. So let's review a little bit. We're going to add vector A plus vector B. So here's vector A. And here's vector B. Let's make it something like that. So now vector A and vector B have somewhat different magnitudes and directions. But what we said before is that when we want to add them together graphically, you just hook them up head to tail. Now, one of the properties of vectors, as we discussed, is that as long as the vector has the same length and is in the same direction, I can pick it up and put it anywhere I want, and it's considered to be the same vector. So let's pick vector A. Let's say, okay, vector R, the result, we're going to call that the resultant vector. R is equal to vector A plus vector B. So let's add A. So we'll pick it up, and we'll put it down here. So I'm going to try to draw it the same. Something like that. Okay. And then vector B, we'll pick it up, put it on head to tail with that. And of course I kind of went into there, but so here's vector A and here's vector B. And we said that the answer, now I didn't draw this perfect, okay, but this is just pick this up, same magnitude and direction. Pick this up, same magnitude and direction. So the answer is vector R starts where A started and ends where B ends. So there's my vector R. Looks like that. Something like that. Okay? And that's what vector addition is when you do it graphically. Now, if you use a protractor and a ruler and you make scale drawings, you can get very accurate answers for R, for the resultant. But let's say we want to add them together mathematically. And let's suppose that A, let's just say that this is what's given. A is equal to 10 meters, and it's at a 30-degree angle. That's what I tried to do, is make this like a 30-degree angle here. Okay, and then we're going to add it plus vector B, and we're going to say vector B is a little bit shorter. Let's just say it's 6. And let's say it's at a 45-degree angle. Okay? Now, you want to add these together mathematically. I'm going to show you what you do not do. Don't do what I'm about to do. Naive students will say, oh, well, A plus B, let's just add them. It's 16 meters and 75 degrees, and we got it. No, you don't have it. You've got it completely wrong. If you do this on the test, and you will have a test where you have to add vectors together, you do this on the test, boom, minus 10 points. No partial credit. Sorry. So it's bad for you. It's also bad for me, because every year somebody does this. Every year somebody adds vectors together like this, and it causes a little stroke, okay, or a little tiny burst in my blood. My blood pressure goes up, and folks, I'm getting old. I don't have anything to lose, okay? So please, for your sake N for mine. Don't do this. Bad. This is bad, 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 bad. Okay, so what do we need to do in order to add vectors together? Well, what we need to do is first break them up into what we call components. And here's what we mean by components. Let's redraw vector A, but now I'm going to put it on an XY plane. So here's my Y direction. Here's my X direction, so XY plane, and we're going to draw vector A. We're going to put it down here. So here I'm trying to repeat what my drawing again. Okay, there's A. Now notice that A has a magnitude and it has a direction. Okay, that's supposed to be 30 degrees right there. But here's what we're going to do. We're going to say, look, in order to go from here to get up to here, we can also do this. We can go along the X direction, and then we can go up in the Y direction. In other words, I can take this A vector and break it up into two parts or two components, right? Components, the component of some machine, right, are all the parts that make that machine, right? Well, here's a vector A, and we're going to say it has parts. It has an X part, and it has a Y part. Or, using the vocabulary properly, it has an X component. I'm going to call that A sub X. And I'm going to call this the Y component, A sub Y. Now these are vectors. They make a right triangle, don't they? But they're really vectors. Here's an AX vector. Here's an AY vector. And we can say that vector A is equal to vector X plus the A in the X vector plus the A in the Y vector. Okay. Now, what is A in the X and what is A in the Y numerically, given what I said that that A is 10 meters and 30 degrees. Okay, well, let's figure that out. How do we figure out what the X component is of the A vector? Well, it's just a right triangle. We just use right triangle mathematics. This is the adjacent leg of a right triangle. Remember that cosine of an angle is defined to be AX over A, right? The adjacent leg divided by the hypotenuse. Multiply both sides by the hypotenuse, and what we get is that the X component is just the magnitude of A times the cosine of its angle. Okay, well, what is that? Well, that's 10 meters times the cosine of 30 degrees. Well, 10 meters times the cosine, put that in your calculator, and you will get 8.66 meters. Now, what is A in the Y? It's equal to, well, I'll just say A times the sine of theta, which is 10 meters. Like this is the magnitude of A times the sine of 30 degrees. And I think you can all see that that's just 5 meters. I can do the same thing for vector B. Let's do that. Now, of course, when you get used to this, you don't have to draw the XY axis every time for every vector, but for right now, let's just do that. 45 degrees. Right? And, well, I drew it a little too long, but that's okay. It's 6 meters. This is B, this is vector A, this is vector B. So we got B in the X, B in the Y. Now notice I'm kind of drawing these as dashed lines. It's traditional to draw component vectors as with little dashed lines instead of solid lines. Doesn't really matter right now. And then we could say, all right, well, by is equal to b times the sine of 45 degrees. So by is equal to 4.24 meters. I just did the math in advance here to make it a little quicker. Bx is equal to 6 meters times the cosine of 45 degrees. Of course, that's the same as the sine of 45 degrees, so you get 4.24 meters. So we have the x component of b, I've got the y component of b, I've got the x and y components of vector A right here. Now, let's write down vector A again, but with the numbers that we got. We got vector A is equal to 8.66 meters in the x direction. Hope you can see this. Plus 5.00 meters in the y direction. Oh, bloody murder. Look, this, I don't want to have to write this every time. Look, I can't add the 8.66 plus the 5, okay? You can't, you know that. You can't do that. You have to say, okay, this is the x component plus the y component, gives me the whole thing. But I need an easier way to say, this stuff is in the x direction. And I need an easier way of saying this stuff is in the y direction, and there is an easier way to do it. And they're called unit vectors. Okay, so let me show you how we're going to do that. Well, I'll show you with this part right here. We have a little symbol that means, by definition, it means in the x direction. I with a little caret on it. I hat. J hat. J hat. Yikes. Okay, that seems kind of weird. Well, don't worry about it. It's something new for most of you, I believe. But you'll get used to it. It's just a little symbol that literally means in the x direction, in the y direction, or in the z direction. So let's talk about unit vectors. Okay, I hat. I is in the letter I. This is just how you pronounce it. It's pronounced I hat. Now, it is a vector. That is, it has a direction, and that direction is in the x direction. But why do we call it a unit vector? And well, let me talk about that. This, by definition, this I hat means one in the x direction. One in the x direction. Now this is where we get the word unit from. Unit as in unity, and unity is a fancy physics word that means one. Now the irony is we call them unit vectors, but unit vectors don't have any units as in meters or newtons or inches or anything like that. They're dimensionless. They don't have any dimension associated with them. And you'll see why in a minute. I'll explain why in a minute. J hat equals 1 in the y direction. K hat, we pronounce it K hat, by definition means 1 in the z direction. And it's this one that gives it the title unit vectors. One is in unity, okay? Because here's what we're going to do. Let's look at vector A again from the previous sheet of paper here. Here's vector A, right? 8.66 meters in the x direction. Well, it's just way easier to say that vector A is equal to 8.66 meters in the x direction. See how I just said the words when I put the I hat there. In the x direction. Plus 5.00 meters in the y direction. In the y direction. Okay. Now, we put the 1 in there because treat this I hat as if it is a factor. That is, you're multiplying like this times this times this, right? This is the value. This is the dimension, and this is the direction, and we're kind of multiplying them all together. 8.66 meters in the x direction. We're going to add that to 5.00 meters in the y direction. Now, vectors exist in 3 dimensions, but in this case we chose A and B vectors to be just in the x and y direction, but it's very easy to just extend this to the z direction, and z direction is shown with this k hat vector. Now you might ask, why I, j, and k? Why don't they use x, y, and z? Okay, and they do actually. Later on in your physics training, you will see x hat, y hat, and z hat to mean in the x direction, in the y direction, in the z direction. Isn't this a lot easier? Sure, it is, but you guys are new at doing this. And what would happen if somebody said, well, vector A expressed in terms of some is 3x squared in the x hat direction. Well, what is a beginner going to do? Well, they're going to say, oh, that's 3x cubed. And that would be completely wrong. Okay, that's not right. This x hat doesn't mean the same thing as this variable x. They mean different things. This just says in the x direction. This is just squaring what your position is on the x-axis. So you can't, so to relieve you of that confusion, they decide to use I, j, and k. But if you become a physics major in your junior or senior year, you kind of drop these I, j, and k hat unit vectors and use the x, y, and z hat vectors. So I'm sorry I even brought it up, but this is what we're going to use. This is what you're going to see on the AP exam. This is what I want you to do. Use I hat, j hat, and k hat to as your unit vectors for the x, y, and z direction. Okay, those are unit vectors. So now we're ready to express vector B in unit vector form. 4.24 meters in the x direction plus 4.24 meters in the y direction. And we're pretty much ready now to add them together, but still, let's add them together graphically first. So I'm going to do that. So here's the x-axis and the y-axis. So let's draw vector A, and it doesn't matter what order you add them. So here's A, and then here's B. A and B. Well, let's break up A and B into their x and y components. So here's AX, and here's AY. Here's BX, and here's BY. Now here's vector R. We can also say that R has an x component and a y component. And what do you notice about, let's say vector R has an x component and a y component. And notice, see, here's my x, the value and units of my x component, and there's the direction, the unit vector that means direction. Okay, now, what is R in the x direction? What is our result in the x direction? Well, A went this far in the x direction, and B went this far in the x direction, and so R just went, it's the sum. It's just, you're just going AX plus BX. So Rx is just equal to AX plus BX. You're just adding them together as if they're scalars. And then you're going to do the same thing for R in the y direction. It's just AY plus BY, right? A in the y plus B in the y. And don't worry, if B, let's say B was off in this direction, that means it's got a negative, or its x component would be to the left or negative, so you would just be adding a positive plus a negative number, and you could do that quite easily, no problem. And so what are we doing? We're adding like components. So when you add vectors together, you add like components. Okay, so let's do that. Well, I've got it set up here, so look. I can just say that vector R is equal to, well, add the like components. I hat plus I hat, you know, it's just going to be I hat. It's common, kind of like a common factor. Treat the meters like it's a common factor. And now we're just going to add together the quantity of that. So 6 plus 4 is 10. So 0, and we've got 9. So that's 12.90 meters in the x direction, plus, and this is 9.24 meters in the j hat direction. And there's my answer. That is the result in rectangular coordinates from adding vector A plus vector B. Okay? Now, sometimes this is good enough. If they just say, what is the resultant vector, and they don't tell you to find the magnitude and direction, then you can just leave it like this. I don't care. This is good. But read the problem carefully. If the problem says, what is the magnitude and direction of the result of adding this vector plus this vector, magnitude and direction, that means you have to give the answer in polar coordinates. So, but this is pretty easy, and you should know how to do this. The magnitude of vector R is just its x component squared plus its y component squared and if you do that, you know, plug it in your calculator. Let's see, I already did it earlier, and I think it comes out to be 15.9 meters. Pretty close to 16. Remember when we added them together badly? We got 16 meters. Well, it's not quite 16 meters. 15.9 meters. You know, pretty close. Now, what's the angle? Well, remember, said when you convert from rectangular coordinates to polar coordinates, you have to use inverse tangent of the y component over the x component of my vector. meters cancels. And when I do this, I get 35, where did I put it? 35.6 degrees. And I did it on my calculator. Now remember to check. Do I need to add 180 degrees to this angle? Do I need to? No. Because why? The x component is positive. And since the y component is also positive, we're in the first quadrant, and when you use inverse tangent on your calculator, you get the correct answer. So our vector r in polar coordinates is now 15.9 meters in magnitude at an angle of 35.6 degrees from the positive x-axis. And there's my answer. And that's how you add two vectors together using mathematics. Okay, so let's review a little bit. What did we do here? Let's see, what did we do? Well, we reviewed adding vectors together graphically, like we did before. But remember, if you're going to add them mathematically or analytically, you may not, you cannot, you will not add the angles and the magnitudes together like this, because that just will cause a lot of pain for a lot of people, okay, including yourself. Okay, so in order to add them together, you have to break them up into their x and y components. So here's vector A. Break it up into its x and y component using trigonometry for both vector A and for vector B, and express them using unit vectors. Okay, and remember that unit vectors is just a very convenient way of saying, hey, this stuff, whatever it is, it's in the x direction. The stuff with the j hat is in the y direction. The stuff in the k hat is in the z direction. Then you could just add up all the stuff that's in the x direction, add up all the stuff that's in the y direction. You've got your answer in rectangular coordinates expressed with I, j, k unit vectors. And most of the time that's good enough. But if they ask you what is the magnitude and direction, you have to change your answer to polar coordinates as we did right here. Okay, so that's it. I think we've covered it pretty well. If you have any questions, you can email me, or if you're watching this in class, you can ask me right now.